Hi, I'm David Bethke, PhD researcher at Porsche and LMU Munich, and I will present our paper vMotion, using driving context for indirect emotion prediction in real time. This work was done in collaboration with Porsche, LMU Munich and TU Darmstadt. Here you see me driving. What do you think? How am I feeling at this moment? From looking only at my face, detecting emotions is hard. Now let's have a look outside. From this video, we can extract multiple contextual data. The weather is nice, no traffic jam, the road is comfortable to drive, and the speed limit is suspended. Can you make a better guess at how am I feeling? I'm actually feeling good. As you can see, detecting emotions using camera-based systems is challenging. However, considering the environment can provide better estimates of driver emotions. This stands in stark contrast to existing approaches, which utilize cameras for detecting emotions within the car. We have seen many companies offering similar solutions, but within our study we were not able to extract any meaningful information from the camera stream of the driver. We were able to observe emotions while the people were interacting with others in the car, but while they were driving alone, their faces showed no expressiveness as I did. And that's exactly what we built. Let's show you how. We present vMotion, a mobile and personal computing software that predicts driver emotions based on contextual driving data collected only by a smartphone. Now you might wonder, what are emotions exactly? There's not just one definition of what emotions are. However, it can be described by a complex psychophysiological ongoing and a strong feeling of deriving from one's circumstances, mood, and relationship with others. There are two concepts to describe emotions: describing emotions in in two dimensions, valence and arousal, so positiveness of feeling and how strong the feeling is, and two discrete emotion categories, so-called basic emotions. In our paper, we look at the discrete emotion categories. We perform a layered approach of extracting relevant context features to learn as much as possible from the driver's driving context using a minimum set of input streams. These are the following requirements. First, on-device computation without accessing the car itself. 2, no direct user interaction of the vMotion system. And 3, non-critical consumption of device resources. Let's look at the architecture. vMotion extracts the vehicle speed and acceleration using the GPS sensor. We retrieve also the road type, such as the number of driving lanes and maximum speed, and the current weather condition on this road segment. The real-time traffic flow on this road segment is also extracted. To include more subject variant features, we added daytime, age, and felt emotions before the ride as input variables to our system. And the facial expressions coming from the camera stream, which does not represent our label for predicting emotions of the driver, but is used rather in a way to have more inside view information. This input stream can be added optionally. All these contextual features are inputted into a sensor fusion module, which aligns the information of each stream. To collect a baseline of the participant's own interpretation of emotional states during the ride, we trigger a beep tone every 60 seconds for the participants to verbally provide their currently perceived emotion. This felt emotion is extracted from the audio stream via a speech-to-text algorithm and represents our label to our classifier and is inputted to the machine learning engine. Now the machine learning engine can learn in two ways: training only on one participant or one driver, or learning a global model which pools all data from all participants together. In total, we have 12 participants who drove their own selected route with a mean duration of 16 minutes. Now let's look into the results. Here you can see some of the results of vMotion. On the left side you see, however, the confusion matrix of facial expressions only. On the x-axis you can see the predicted facial expressions, and on the y-axis the true expressed emotions by the participant is shown. We can clearly see by the blue vertical highlighted values that the facial expressions engine predicts neutral emotional states for most of our observations and therefore fails to predict most self-reported emotions. The facial expressions predict driver emotions which weren't even self-reported by the participant, such as contempt and sadness, as can be seen by the additional elements in the x-axis. On the right, you see the confusion matrix of our classifier system vMotion. Looking at the distribution of the blue highlighted boxes on the diagonal, we see that vMotion is able to predict emotions more confidently. The overall accuracy of vMotion is 71.7%. In other words, it's 29% better than relying on facial expressions. We validated other common facial expressions engine classifier, but the results remain the same. The results indicate that contextual information can significantly improve the classification of emotional states, especially in detecting surprise situations. vMotion is also discriminating better between neutral and happiness states of the driver. These results of vMotion are not perfect, but they recognize emotions in the wild pretty confidently. Now let's look into what vMotion can achieve on different evaluation schemes. We look at learning global classifier models and validating on a holdout route segments. We looked at individually trained models and asked the questions, how good is our classifier if we do not know anything about the driver in advance? On the left side, you see different classifier system, facial expressions, vMotion, and vMotion including facial expressions. Looking at the first evaluation, we see that facial expressions only achieves an accuracy of 56%, whereas vMotion is able to predict emotions with 72%. This significant difference shows that we are able to predict emotions based on context much more better than using facial expressions. Also, adding facial expressions to our classifier does not improve performance. These results remain the same for the other evaluation setups. Thus, our in the wild study does not show a significant benefit in including facial expressions as features in our classification model. We propose omitting facial expressions in practice, which would further reduce computational cost, and they inhibit largely privacy concerns of the end user and might raise a feeling of video surveillance while driving. Detecting emotions while driving remains a challenge in HCI. Can we now predict driver emotions based on driving context? To the best of our knowledge, vMotion provides the first in-car sensor that combines implicit and non-intrusive measures to detect the driver's emotional states only by using a smartphone. Using driving context can predict emotions. And we present a model that can predict driver self-reported emotions only by using a smartphone. It is a very hard task to reliably recognize emotions in car. Current state of the art as the use of facial expressions or driver voice analysis exist, but they have to be tuned individually or compromise the user's privacy. Body-worn sensors circumvent some of the issues, but from a usability perspective, remote sensing is still desirable. There's a growing interest in developing automotive user interfaces that allow for implicit and explicit interactions that are aware of how someone is feeling in the car. vMotion allows the implementation of several use cases. However, our work intends to make a sensory system contribution of unobtrusively measuring emotions in the wild. We are able to predict emotions on the road in real time using our vMotion sensor. Here you see our real-time app. In the past, we have demonstrated that how we can choose the best route for the driver according to different environmental points of interest, like choosing a route through the mountains or by the sea. And we think that this could be extended by emotional factors, generating a great driver experience, as we can now predict emotions on unknown roads on an individual driver's basis. In future work, we would like to reflect this environment-emotions relationship and expand this work, including outside view camera input. Thank you for listening. Check out our paper, Code and Data of vMotion.